So the last class kita belajar sampai slide yang mana satu eh? Okay, saya tanya semula, slide yang terakhir kita, kelas yang terakhir, slide yang mana satu?
The LC 305 slide, sir.
LC 305. LC3, LC05 is a chapter. LC3 is the software name. Okay, ada 11, ada 10 orang. Ada 10 orang dalam kelas ni. Actually ada berapa orang semua eh?
Usually I think 13.
13. Sepuluh orang. Hafiz ada, Hafiz. I double check with the WhatsApp group. In WhatsApp group, we have about um, about 20 participants. If excluded me, it's about 19 student. So sekarang kita ada 10 lagi 9. So, siapa yang tak masuk lagi? Ada tak kawan-kawan awak yang tak masuk lagi? Saya tanya sekali lagi, ada tak kawan-kawan yang tak masuk lagi?
Ada seseorang tu, Fatin Nabila. Dia cakap line dia tak apa nak okey.
Fatin Nabila, so ada 12. 11. Okey, lagi? Anis Natasha.
Yes, sir.
Ada tak kawan-kawan? Saya tanya semua orang tak ya, ada tak kawan-kawan yang tak masuk lagi? Semua orang saya tanya ni, tolong respon ya. Kalau tak respon, saya keluar kelas. Ada tak kawan-kawan yang tak masuk lagi?
Ada kot tapi saya tak kenal lah sangat dia orang ni.
Okey, yang lain, takkan saya nak sebut satu-satu. Maizatul Syuhaida.
Tak kenal yang lain, sir.
Azrina. Eliza Hafiz. Weakness tak masuk, weakness.
Belum kot sebab dalam ni tak ada pun nama dia.
Susah lah. Susah sebab ramai yang tak ada ni. I don't know how to do. Kita dah tak buat kelas for 2 weeks. The first week kita ada perjumpaan di SITC. Itu arahan TNCA supaya kelas dibatalkan. And last week ada bengkel pensyarah. Semua pensyarah kena pergi bengkel, so tak ada kelas for 2 weeks. Kita tak ada kelas. So kita dah tertinggal banyak step and chapter sampai saya dah lupa apa saya ajar. So sekarang saya menghadapi masalah untuk menyambung semula kelas because I can't remember di mana kita di mana kita stop our lecture and sejauh mana progress kamu. Sebab untuk kelas satu lagi pendekatan saya lain because based on response from students, and for this class I tak tahu nak start kat mana. So as for today, untuk memulakan kelas saya akan mulakan dengan bilangan pelajar lah. Nak tengok siapa yang ada, siapa yang tak ada. Saya tak boleh jump into our content sebab content pun saya tak tahu kat mana. So that's why saya hantar tadi, tengah hari tadi, saya hantar mesej dalam WhatsApp, tolong review balik ataupun study balik apa yang kita belajar during the last class. That means I need your help to manage this class. So tadi first of all student attendance ada 10 orang je ni. I don't know what's happened to others. Lagi berapa orang, 9 orang ni tak tahu mana pergi. Kalau you all tak bantu saya tak boleh bantu you all if you are not helping me, I can't help you. So how Kuan beritahu tadi, kita stop dekat chapter 5. Okay, so kalau bagi tahu maklumkan pada saya kita stop pada chapter 5. So pada chapter 4 lah. So we have learned about chapter 4. Itu logically, secara logiknya saya fikir begitu ya. Okay, ada sebarang bantahan, maksudnya kita tak masuk lagi chapter 5.
So we are learning chapter 5.
Until which slide?
Slide 34, but you went straight to slide 34 to teach us the ISA.
Straight to 34.
Yes.
Straight to 34 means what's the last slide before this 34?
Sorry, sir.
You told us that I just go straight to slide 34. So what's the slide before slide 34?
Chapter 4.
Chapter 4 and directly go to 34.
Yes.
What's the relationship between the chapter 4, the last slide, and slide 34? Can you guys tell me? I need to recall every single thing.
So you were teaching the instruction processing, which is fetch instruction from memory and then decode instruction. Then you teach us how to understand the comments, how to understand the address and instruction.
Okay, wait. I open up chapter 4. Okay, instruction processing. This one. So we have gone through each of the phases, isn't it?
Yes, I think so.
Okay, so if that's the case, wait. Okay, chapter 4 is actually it's overall is about instruction processing, where it begins with the von Neumann model. Okay, this one. So if this is the last point or last slide that we have learned before, so I want to make sure all of you understand what is chapter 4 all about. So okay, can any one of you tell me what is chapter 4 all about?
Chapter 4 is about how we can fetch information and then how to process the information and then store the information.
How to fetch, process, and store the information. The information or the data?
Oh, data, sir.
Okay. Oh. Okay, normally we have 4 components in von Neumann model, which is input, memory, processor unit, and output. And all of these components are controlled by control unit. So that's the foundation. And then all the data will be all the data were kept in the memory. when we want to process the data. Macam mana nak terang? And someone of you actually macam ni, for the for other class, the way how I describe the slide is different in your class, if compared to your class. So that makes me confused actually. What is your understanding towards this chapter? So I don't know which sentence that I can start this class. Saya tak tahu progress awak macam mana. So that's why I ask you so that I can start, so I can assess how deep I tell you or I describe or I explain about the slide. So can someone of you tell me in details, more detail than before, what is the instruction processing procedure or steps in general? I mean the component that involve, and then what is happening during the process, okay, starting from the input until to the output, and then see we have load, we have store, the component that involve in load and store, the function of LU, temp, and everything, and then how does the instruction is fetched from the memory and how it is decoded. Okay, itu masalah sekarang. That is a problem now. So when told me that I just go straight to slide 34, what I can imply from the information is I've already told you or teach you about how to understand or write a command for the instruction. For example, like slide 11. In slide 11, there's an example 0001 So how to read the instruction? So just refer to the IC table, and from the IC table we can determine which bit is representing the opcode, the destination register, the source, the first source, and the second source. So once we know about the location or the bit that represent those variables, so we can, from there we can create a command. For example, add the content of R2 to the content of R6 and store the result in R6. So here how we do a command or understanding, or what we call, we try to understand what is the language or instruction is about. Same goes to slide 12. So to conclude or to give more example, that's why we go straightly to chapter 5, slide 34 as told by Ho Kwan. Kalau itulah, kalau betul, saya tak tahu sebab you all semua diam, you all semua tak bagi respon, so saya tak tahu apa nak cakap. So if it is true apa yang saya cakapkan tadi, so for the next slide, it told us about the details of the process one by one. Okay, so kita ada 9 orang dalam ni. We have about 10 to 11 students in this class. So can any one of you tell me what is the detail of each of the phases in instruction processing in your own word? Kita dah belajar, you have learned about MAR, MDR, the uses, the usage of MAR, MDR, ALU, TEM, IR, PC. We have learned about it before. So this slide towards the end is only the detail about all of the steps included in those phases. So can anyone tell me, anyone of you, mean step by step what's happening in fetch and everything until the store phase?
So we haven't learned this yet. We only learned how to write the comments from last week.
Yes, sir. We haven't learned this yet.
If that's the case, Can you, okay, macam mana nak cakap we all learn about this, and I already told you about the function of MAR, MDR, the registers, boost registers, the uses of boost registers, the temp, the ALU. Ke langsung tak cerita?
Already, sir.
Already kan, apa nama saya dah introduce the function of all of these components. Sama je actually. That's why I suruh you baca slide tadi. Sama. What are the things? What were the things that I've already told you, and the details that you can get from the slide, starting from slide 13 towards the end. Sama je kalau you baca ni. You baca ni, copy contents of PC into MAR, send read signal to memory, copy content of MDR into IR. You boleh baca satu-satu. And then increment of PC so that it points to the next instruction in sequence. Identify the opcode. Semua ni ada. So, okay. Contoh, macam I dah, like in the slide 34 in chapter 5, this is the example of the instruction. It has address and following by the instruction itself. The 16-bit of instruction. So this is the address. Address is it addresses the other name of the address is PC, program counter. So the program counter is always increase one by one. That's why in chapter 5, slide 34, you can see the PC is increased one by one. There, slide 34, you can see the address there. 3000 A, B, C, D, E, F, 10, 11, 12, and so on. This is increasing one by one. You can see over here. This is the address in hexadecimal. That's why after 3000F is 3010. I hope that you still remember how to calculate the number in hexa. Lepas 3000F is 3010. Lepas F is 10. Lepas 9 adalah A. After 9 is A. After F is 10. Remember that. Saya tak nak awak lupa-lupa lagi. And you can see the other slide, 33, you can see the address is increased one by one starting from 3000 until 3009. So that's the meanings of PC equal to PC plus 1. So it means if the current PC is 3000, so the next PC plus 1 is 3001. Itu maksud dia. That's what it means. If the current PC is if the current PC is 3005, so the next PC will be 3006, which is PC plus 1. Get it? You get it?
Yes, sir.
Itu maksud PC. That is the meaning of PC equal to PC plus 1. Ada soalan setakat ni?
No, sir.
Nur Iliana binti Nur Hisham. Ada berapa komponen dalam von Neumann model? Dalam memori ada apa? MDR. Apa gunanya? Cerita semua tu, cuba cerita balik, bagi saya proud of you, bagi saya bangga sikit dengan korang ni. Janganlah macam tak tahu apa-apa langsung. Saya penatlah nak ulang balik. Sebab kita dah ketinggalan banyak sangat.
CPU. And then once the CPU has processed the data, it will send it back to memory again, and then send to output.
Okay, itu is the first knowledge that you need to know. Okay, and then after we learn about load and store, so what is different? What's the word or keyword that you can use to replace? I alert that you use word send from memory to CPU and send back. All the word is send. So how about load and store? What is load and what is store?
Load is send the data from memory to CPU.
Okay, Anis, can you improvise the sentence that used by the
Apa dia sih?
Improvise, perbaiki balik ayat yang digunakan oleh tadi. Dia kata send data to CPU and then send back to CPU from CPU to memory. So can you improvise the words? You know where to put the store and the load. So use that word. Awak dah tahu tadi dah. So guna saja ayat tu. Jangan start daripada input. Just get it start from the memory.
Proses load ke sir?
Cerita semua yang awak tahu. Jangan tanya saya apa yang awak tahu.
Load is send data from memory to CPU.
I mean, tak faham, saya faham. Awak faham maksud saya ya. Tadi soalan asal saya adalah ceritakan pada saya apa yang berlaku daripada input ke output, and telah pun menceritakannya. Already told us what is happening from input to output, settle. But his word is not detail. Itu isu dia sekarang. Ayat-ayat tidak detail sebab dia menggunakan perkataan hantar. Hantar data daripada memory ke CPU dan hantar semula daripada CPU ke memory. That one is not detail. So I want you guys, anyone of you, help to improvise his word. Itu satu. Yang kedua, please use keyword which is store and result, store and load. Saya bagi hint, which is perbaiki ayat dengan menggunakan dua hint itu, load dan store. So ceritalah balik apa yang cakap dengan menggunakan dua keyword tersebut. Semudah itu sahaja. Okay, ceritakan. Siapa yang boleh cerita? I think Anis is okay. So please, Anis, you proceed with your understanding.
Untuk proses load, first control unit akan tulis alamat ke dalam MAR. Lepas tu dia akan send signal read dalam memory. Data CPC lokasi data yang telah dipulangkan kepada MAR akan diregister dalam MDR. Lepas data dah
Anis sekejap. Okay. Boleh repeat balik tak ketiga-tiga step yang awak cerita tadi? Sebab ada kekeliruan kat situ. Apa yang berlaku tadi mula-mula? Control unit
control unit tulis alamat dalam MAR.
Okay, control unit akan tulis. Okay, tulis tu actually register.
Okay.
Guna perkataan register. Daftar.
Okay.
Untuk semua sekali, jangan ulang-ulang balik so please jot some notes. Okay, so the control unit will write the address or will register the address into MAR. So where is the address coming from?
Lepas tu dia hantar signal read.
Sekejap. Tadi you kata, you told us that control unit will register the address of the content that we want to load from memory to CPU. So that's the first thing. Okay. So address tu sendiri, where's the address coming from? Look at the slide 13 yang dah tunjuk tu. Where's the address coming from? It's coming from, siapa boleh bantu Anis? Ada 5 orang dalam ni. Can anybody help Anis? Where's the address coming from? Where's the control unit get the address? Daripada mana?
Dari PC.
Dari PC. PC dekat mana?
Input ke sir?
PC is a subcomponent of which component?
Control unit.
Control unit. Seorang dia yang jawab. Yang lain macam mana? Dah lupa ke volume model? Awal-awal tadi saya tunjuk. I've told you what is the content of volume model. Jangan lupa. 10 kali aku ngajar, 10 kali ulang, penat tu. Lepas tu dah dapat dah balik. The address, the value or the address is registered into MAR by the control unit. So the address is coming from PC. As I told you, the address is a PC. It's always increased one by one. Okay, so let's say the current instruction being processed is, the address of the current instruction is 3000E, for example. So that 3000E will be copied into MAR. Example bawah ni, I give you already the example there. At the bottom of the slide, 3000E, and then the 16 bit of instruction. So that is example. So in this case, copy content of PC into MAR, it means we copy 3000E into MAR. So now we have the address already in the memory. So what's next?
Data yang dah dipulangkan ke MAR akan didaftar dalam MDR.
data yang telah dipulangkan dalam MAR, what do you mean data yang telah dipulangkan dalam MAR? Kenapa pulang? Kenapa guna perkataan pulang? Boleh saya tahu justifikasi?
Saya baca dari note saya, sir.
Nota awak kurang tepat. Siapa boleh bantu? Kita dah register dah. We already have the address in MAR. Where the address is coming from the PC in control unit. So what's next? What is happening when the read signal is sent to memory? Apa yang berlaku?
Kalau ikut yang saya tulis ni, the data of location that has been returned to MAR will be registered in MDR to CPU.
Ni apa awak cakap tu? Saya tak faham. Kenapa ada perkataan return? We haven't written anything. We haven't processed anything yet. Nothing is processed. Macam mana boleh kembalikan? Macam mana nak store, pulangkan semula, pulangkan apa, kita belum keluarkan lagi pun. Kita belum ambil lah, kita belum apa tadi, load lagi. We haven't load the data. How come we can return the data yet? At first stage, cannot. It's unlogical. Kita baru je tulis alamat dalam MAR, baru je register. We just register the address into MAR. So what's next? We know that the next one you can see from the slide, send read signal to memory. So control unit will send the read signal to memory. So what is happening during this step? Alamat dah ada, kemudian
load data from based on the address.
load the data in where? In the
From MDR to CPU.
No. It told us that we after we know the address, we find out the data, the location of the data. Where is the location? In which component?
Location is in MAR.
In the memory lah sayang oi. Dalam memory lah locationnya. Location ni kan banyak.
Address.
Ayo. Kita dah ada alamat guys. We have address already. So we want to locate the location. We want to find out the location. So where is the location? It's in the memory lah. The location of the data in the memory. So what's next? After we found the location, what's next?
The CPU will
Nanti
load data.
dulu. Itu jauh sangat tu. Kita baru jumpa data dalam memory ni. Kita dah ada alamat, we already register the address in the MAR. That's the first one. And then we find out the location based on the address. In the we find out the location based on the address to find out the data itself lah. So after we find out the data in the memory, what is the next process? Data dah ada dalam memory ni, kita nak bawa keluar ni, apa kita buat? Guys, You ada satu tempat tu simpan barang, dalam tu ada banyak barang. So bila you nak cari barang tu, apa yang you perlu tahu dulu? Katakan ada banyak almari ni atau cabinet to keep all the stuff. Okay, the first tadi you find out the address. So means that you find out which a cupboard or wardrobe that used to keep the data or the things that you want to find out or take it out. So now you already find out the cupboard based on the address. And then you already got the data or the things that you want to get it out. So what's next? Macam mana You all macam tak ada pengalaman langsung lah. You all pernah tak attend program?
Pernah.
Mana-mana program? Have you attended any programs in university or college?
Pernah.
So apa yang you buat masa you attend the program? You terus masuk dalam tempat tu ke?
Daftar dulu.
Daftar dulu. Kenapa kena daftar? Kenapa kena daftar?
Sebab nak masuk.
Sebab apa? Tak payah fikir jauh-jauh, simpan maklumat lah apa. Tak payah fikir, tak payah guna ayat yang terlalu teknikal. Apa guna register tu sebenarnya? You all pernah jadi AJK kan? Kenapa nak register?
Sebab nak masuk.
Sebab nak masuk, memanglah sebab nak masuk. So lepas dah register tu, apa kita nak buat dengan list tu? Nak koyak bakar je ke? You all sebagai AJK, let's say kalau you all sebagai AJK pendaftaran kan, apa gunanya list pendaftaran tu?
Untuk MyCat.
Untuk MyCat tu okay, itu dia punya macam reward lah. You datang, you dapat reward. Ni apa gunanya register? Let's say kalau tak ada MyCat. Cuba buka sikit minda you, kalau you pergi kat luar, program luar yang tak ada MyCat, persatuan-persatuan, program apa kat luar lah. You register, untuk apa register tu sebenarnya?
Untuk kehadiran.
Apa
Untuk kita
gunanya?
tahu yang kita join program tu.
Untuk kita tahu ke untuk organizer yang tahu?
Organizer.
So lepas, lagi-lagi apa gunanya pendaftaran ni?
Untuk store data.
Untuk apa? Apa dia?
Store data.
Store data tu tinggi sangat. Apa gunanya pendaftaran ni? You all tak pernah join program ke? You all tak, ada tak kat sini tak pernah join program langsung? Tak tahu dekat sekolah pun tak pernah join program. Ada tak dalam 10 orang ni? 11 orang? So kenapa kena guna daftar ni? Kenapa kita kena mendaftar?
Untuk tahu bilangan peserta.
Untuk tahu bilangan peserta. So apa gunanya bila you dah tahu bilangan peserta? Apa you boleh buat bila dah tahu bilangan peserta banyak mana?
Sediakan tempat.
Lagi?
Bajet.
Lagi? You all tahu tak apa yang you belajar dekat sekolah, dekat universiti, kenapa kena join all those activities selain daripada masuk ke kelas adalah untuk belajar mengurus. You all sedar tak benda tu?
It's 3 o'clock.
You all kena mengurus tau. Hidup ni tentang urusan. You nak kahwin pun you kena register your marriage, you know, if you want to get married. Kalau you beranak pun you kena register kelahiran anak you. Kenapa kena register kelahiran anak you? You sendiri pun ada surat beranak. Why? Kenapa kena ada IC? Kenapa kena daftar IC? Why? Apa akan jadi kalau awak tak ada daftar IC? Awak jangan main-main dengan pendaftaran Nampak macam main-main je pendaftaran register nama untuk MyCat. Itu je yang you nampak. How about your IC? How about your surat beranak? How about your, kalau orang Muslim dia ada right and left kitab lah, kitab kiri kanan everything to write your good action, your bad things. Apa gunanya daftar-daftar ni? Kenapa tiba-tiba ada malaikat tulis kebaikan, kejahatan, ada buku register lagi. Untuk apa register tu? Awak ingat saja-saja ke malaikat nak register baik buruk awak tu? Untuk apa? Tak dengar. Untuk Allah, Allah memang tahu pun. Dia tahu apa yang kita buat. Apa gunanya buku tu sebenarnya?
Bukti amalan kita.
Bukti tu nak buat apa nanti tu? Maksud saya, bila masa gunanya benda tu nanti? Bagaimana ia digunakan? You all tak sedar kan kegunaan daftar ni apa? You all ingat daftar ni satu perkataan yang sangat weird. You guys think that register is very weird word. Actually it's very close to you lah guys. Daftar. Bukan setakat daftar program and then dapat MyCat, my whatsoever my. Banyak lagi daftar, kegunaan daftar. So saya tanya random je tadi, apa guna daftar? Kalau itu pun tak tahu macam mana. Macam mana saya nak teruskan dengan proses yang berlaku, instruction processing ni. You all ada diary tak? Siapa ada diary? Seorang pun tak ada diary.
Tak ada. Kecil-kecil ada rasa.
Apa kegunaan diary tu? Diary pun tak ada.
Untuk record daily life.
Untuk record. Kenapa you nak record diri? Kenapa you rasa you nak record tentang apa yang you buat?
So that boleh tengok balik.
To trace back everything that you did. You boleh tengok balik apa yang you buat. Ke you all tak kisah apa you all dah buat selama ni? Daftar subjek. Siapa yang tak pernah daftar subjek? Mesti nak daftar. Kenapa you daftar subjek awal semester? Untuk tengok bilangan subjek yang you ambil. Kenapa you kena tengok bilangan subjek yang you ambil? Sebab you kena cukup kredit untuk graduate. Untuk you trace back everything. Untuk record. So in this case, tadi alamat kita dah register. And then kemudian kita dah jumpa dah data ataupun we already find the data in that location. And then what we did? What we did is to control unit will send read signal to memory. So what is happening during this phase? Data kita dah jumpa, apa lagi nak buat lepas tu? Kena daftar tak data tu guys? Nak buat keluar daripada memory ni nak kena daftar tak? Apa gunanya MDR?
Store data.
MDR is memory data register. Kita register data dalam MDR. That's why nama dia memory data register. Kita dah daftar alamat dalam MAR. Datanya pula nak daftar dekat mana? Daftar dalam MDR. Bila dah daftar baru boleh bawa keluar. Kalau tak daftar, macam mana kamu nak trace back? Saya tunggu jawapan tu je tadi. Daftar data dalam MDR. Register the data into MDR. Sibuk sangat nak hantar ke CPU. Daftarnya tidak lagi. Mana ada perkataan return dekat situ? Anis tak ada return. Baru daftar nak bawa keluar. Bila dah daftar dalam MDR, barulah boleh copy content of MDR into IR. Cuba cerita balik proses ni. Kalau saya suruh cerita balik, mesti tak faham juga ni. Tak apa-apa you all cerita. Cuba cerita balik daripada tadi. Start daripada daftar alamat dalam MAR.
and then register data to MDR.
What is happening during the send read signal to memory? What is happening there?
Data is being registered to MDR.
Where's data coming from?
Data coming from MAR. Sorry, memory.
Okay, data daripada memory, data from memory you register dalam MDR. How can you find out the data? What is your reference? Based on
the address.
Based on the address. Apa susah sangat nak faham? Senang je guys. Daftar alamat, cari daftar alamat dekat mana simpan data, kemudian cari data tersebut berdasarkan alamat, dah jumpa data, salin copy atau register data dalam MDR. Dah register baru boleh bawa keluar. Itu je. Apa susah sangat sampai 45 minit, 1 hour just to talk about this. Register alamat, cari data berdasarkan alamat, bila jumpa data, salin dalam MDR, register dalam MDR. Itu dah 1 jam. Belum lagi bawa keluar data daripada MDR ke CPU. Itu pun tak, saya yakin ramai yang tak faham lagi ni. Macam mana? Dah lah kita kesetukan masa, you all tak study, lepas tu tak faham, lepas tu nak faham pun 1 jam, benda yang mudah pun tak faham. Tanya pasal pendaftar pun tak reti nak jawab, tak tahu kenapa daftar tu ada, itu pun tak tahu. Habis tu selama ni dekat sekolah daftar buat apa? Itu pun nak kena cerita satu-satu. Itu pun dah 10 minit. Cerita pasal sekolah, cerita pasal daftar AJK Persatuan, nak cakap pasal makanan lah, MyCat lah. Itu pun dah 10 minit. Bila nak habis? Okay, lepas data sudah ada dalam MDR, what next? Ke mana nak bawa data ni?
Data will be sent from MDR to CPU.
Kalau tengok nota dalam ayat tu betul lah tu, ayat awak betul. Tapi awak tengok slide 13 tu, kat mana dia hantar?
IR.
Jawab macam tu. Dah ada dalam slide. Copy content of MDR into
IR.
Jawab ikut slide. Saya tak tanya soalan selain daripada dalam slide tu. And then what is happening next? What happened to the address in the PC? Let's say the current address that registered into MAR is 3000E. So what is the current value of PC? 3000?
3000 E plus 1.
Apa jawapan dia? E plus 1 tu, terus jawab.
3000 F.
3000F. Cuba cerita balik daripada tadi, daripada register alamat dalam MAR sampai 3000F. Siapa nak cerita? Saya takkan bergerak ke slide. Anyone can answer me? Dunzian Lee, Ding Ali, you can answer me too.
Hello, teacher.
Seorang pun tak jawab. Saya tunggu sampai 3 suku Kalau tak ada siapa yang jawab, saya akan cancelkan kelas ni. Saya akan teruskan kelas dengan dan Anis saja.
Sir, the control unit will register address into MAR, and then the data from memory will send to MDR.
Kenapa guna perkataan send? Bila pula memory send to
The
MDR?
data from memory will register to MDR.
Lepas tu?
And then the data from MDR will send to.
Boleh tak kurangkan perkataan send, guna perkataan register dengan copy. Dekat dalam slide dia guna copy. Tadi register and copy, jangan guna send. Dia macam budak kecil tau. Dia guna perkataan yang ayat macam budak kecil, faham tak? Dia tak professional, it's unprofessional. Copy, register, daftar, dia tak ada guna send, hantar. Data hantar ke sini, data hantar ke tu, data hantar. You know, macam you all tak, macam mana cakap boleh tak you all precise ayat tu guna perkataan-perkataan yang matang. Register, copy tu salin. Jangan guna perkataan send. Saya daripada awal tadi kan, bila guna perkataan send kan saya tak puas hati. Saya minta Anis improvise guna perkataan load dengan store. So what does it mean? It means gunakan perkataan yang betul. Sebab kalau guna perkataan yang salah, send sebagai contoh, you all tak boleh differentiate the load and the store process. So tak suruh guna yang the exact word. Kalau macam bila you guna exact word, you tahulah bezakan send yang untuk store dengan send untuk load. So please guna perkataan yang betul. Boleh tak ulang balik daripada awal tadi, di mana alamat didaftarkan, the address is registered into MAR by the control unit. Cuba start daripada situ, guna ayat yang betul, perlahan-lahan. Siapa yang nak masuk dalam kelas seterusnya tolong jawab. Saya dah pilih 2 orang, dengan Anis saja. Yang lain kau nak masuk jawab. If anyone of you want to get into the class, please answer my question. If not, I just invite and Anis sahaja. Both of them to get into my class.
The address will register into MAR by control unit. And then data from memory will register to MDR.
Apa kaitan di antara daftar dengan alamat tadi? Ada kaitan tak? Cuba kaitkan. Jangan tiba-tiba melompat. Alamat didaftarkan dalam MAR, kemudian data didaftarkan dalam MDR. Apa kaitan alamat dengan data tadi? Cuba kaitkan. Kan saya cakap tadi, aku ulang, aku penat betul lah ulang. Saya dah beritahu kan, alamat didaftarkan di dalam MAR, kemudian data akan dicari. Data akan dicari berdasarkan alamat tersebut. Selepas data dijumpai, data tersebut akan didaftarkan di dalam MDR. Kan itu ada kaitan tu? Cari data berdasarkan alamat yang telah didaftar. Ada kaitan kan dekat situ kan tak nampak. Mana ada lompat-lompat tiba-tiba ada data. Data datang celah mana kalau tak ada alamat? Aduh, susahnya nak ajar. Ya Allah. Kenapa jadi macam ni guys? Cuba ulang balik. Ulang ayat saya tahu, bukan buat benda baru tahu. You all ni just copy what I'm saying, you know. Macam budak sekolah, bukannya budak universiti. Budak sekolah, just copy what I'm telling you. Itu je. Itu pun tak boleh. Bukannya suruh study dan beritahu apa yang awak faham. Ulang balik ni cognitive skill level 1 tau. Level budak sekolah. Itu pun tak boleh buat. Cuba ulang balik. 317 jangan saya keluarkan daripada grup ni.
Control unit register alamat into MAR by control unit and then send dekat memory. Lepas tu find out location based on address. Address tu untuk find out the data. Lepas jumpa data, register data dalam MDR and then copy contents to MAR. Lepas
Copy
data
content.
dah ada dan
Apa copy content dalam MAR?
from PC copy contents to MDR.
Copy content celah mana lagi? Tadi dah content tu apa? Apa beza data dengan content? Korang ni kenapa ni? Apa dia? Aku tak faham. Cuba cerita balik .
First, control unit will register address into MAR from PC of control unit, and then send a read signal to the memory, register data from memory to MDR, copy content of MDR into IR, and then finally program counter will increment by 1.
Okay, yang cerita tu daripada first step sampai second step. Saya faham ada beberapa keyword yang dia tak guna. Sebagai contoh tadi, tak kaitkan data yang dicari dalam MAR berdasarkan alamat yang telah didaftar. Yang tu tak cakap. And then juga tak cakap, okay, itu satu point yang tak cakap. Tapi dia cerita tu betul. Dia faham the overall process. Okay. Dia tahu apa yang berlaku, dia tahu kenapa kena daftar alamat, dia tahu kenapa daripada mana datangnya data yang nak digunakan, yang nak di copy dalam IR, dia tahu daripada mana. So sebelum register ke dalam IR pun dia tahu nak register dekat mana, dia tahu the overall process. Siapa lagi yang boleh ulang balik?
Okay.
Siapa lagi nak cerita cepat, jangan tunggu saya. Dah 3.20 ni. Kalau tak saya keluar kelas ni. Nur Eliza and Raisha, you need to try it back. You can retry.
Okay, sir. We register address into MAR by control unit. Kemudian data akan dicari di MAR berdasarkan alamat yang ada di
Data akan dicari dalam MAR. Dekat mana nak cari dalam balik ayat tu? Sejak bila data dicari dalam MAR? Cuba cakap betul-betul. MAR tempat buku daftar je. Cuba lagi, try again Nur Aisyah, Reza, come on. Primalah tak nak try ke? Tak apa, sekadar.
So we register address in MAR by control unit, and then we trace the data from the address in MAR. After that, data from memory will register into MDR. And then we copy contents of MDR into IR.
Mana ujungnya? Kenapa sangkut? Hello? Tak dengar ke suara saya?
Dengar, so.
Dengar.
Siapa Nur Eliza akan jawab tadi, kenapa tak habis? Dah copy ke dalam MAR apa lagi? Saya cakap, saya beritahu tadi cerita sampai mana?
Program counter.
Mana Eliza dia keluar daripada grup ke mana ni? Line hilang ke?
Ada sir.
Betul mana dia? Mana jawapan awak? Lepas data di copy ke dalam IR, apa yang berlaku? Astaghfirullahalazim. Apa yang berlaku lepas tu?
Program counter will increase by 1.
Apa masalah? Dia PC tambah 1. PC equal to PC tambah 1. Kan saya cakap cerita sampai PC equal to PC plus 1. Awak sangkut dekat mana ni, Eliza? Are you there?
Yes, sir.
Awak dengar ke apa kita orang bincangkan ni?
Saya dengar.
Habis tu? Sampai mana tadi?
After copy contents of MDR into IR,
Apa dia?
PC will increase to 1, to plus 1.
Apa yang susah nak jawab? Aduh, nak tunggu habiskan ayat tu pun 5 minit. Lagi siapa nak cuba? Dah 3 orang nak masuk kelas lepas. Sepatutnya 3 suku saya keluar dari grup ni. Ni saya tambah, saya bagi peluang tau. Dah 10 minit dah ni.
Saya try lagi. First, register alamat into MAR by control unit, and then send read signal to memory. Lepas tu find out location based on address, and then based on address tu find out the data. Lepas jumpa data, register the data dalam MDR. Lepas tu copy contents dari MDR tu ke IR, and then the last one is program counter to be PC plus 1.
What do you mean by content of MDR? Content of the MDR tu apa? Apa kontennya?
Copy the data daripada MDR to IR.
Copy the data tu copy content lah, betul?
Betul.
Find out data dalam memory tu berdasarkan apa tadi?
Find out based on address.
Address tu dekat mana? Nak rujuk dekat
Address
mana?
tu daripada address rujuk dari location.
Address tu awak nak cari data dalam memory ni kena rujuk daripada address. Address tu ada dekat mana? Yang boleh dilihat di mana untuk dirujuk?
Location address dari PC.
Tahu sekarang ni address tu dekat mana? Awak nak cari lokasi memory, awak nak cari lokasi. Saya tanya tu sebab awak bezakan perkataan lokasi dan awak kata tadi daftar alamat di dalam MAR untuk mencari lokasi. Kemudian awak cakap cari data di dalam MAR. Faham tak? Apa kaitan data dengan lokasi tu apa sebenarnya? Awak macam tak ada kaitan. Awak faham tak apa lokasi, apa data, apa alamat? Jadi awak cari data tadi tu berdasarkan apa? Kat mana awak?
Berdasarkan address.
Address tu awak boleh rujuk dekat mana? Dalam MAR lah. Awak kan ada daftar dalam MAR. Alamat tu ada dalam MAR. Rujuklah dekat MAR. Nak rujuk kat mana lagi? Takkan nak rujuk lagi dekat dalam PC. Kan dah dalam MAR tu. Aduh, itulah awak kan baru tadi cakapkan kalau kita daftar dalam persatuan ke dalam program ke, kegunaan dia adalah untuk kita buat rujukan, tengok balik siapa yang datang. Nak tengok dekat mana kan dekat daftar. Mana dia tengok dekat rumah awak ada awak buat program dekat college, kemudian awak tengok siapa yang datang, bila nak rujuk balik siapa yang datang awak tengok alamat dia dekat college ataupun kehadiran dia dekat college. Macam tu ke?
Tak.
Awak tengok kat mana?
Tengok dekat yang dia dah daftar tu.
Yang daftar tu lah. Itulah maksud dia. Janganlah jauh-jauh sangat fikir, benda mudah je. Siapa lagi nak try? Ada 4 orang nak masuk kelas. Lagi siapa? Every one of you need to try. If not, you are not allowed to enter the class. Sebab memeningkan kepala saya dan menyebabkan saya panas, sakit hati. Saya nak buang semua all the negative vibes. Siapa nak masuk, cuba. Kalau tidak, jangan masuk kelas saya. To anyone who want to get into my class, please answer this question. If not, I will dismiss you from the class because I want to get rid all of the negative vibes. Tukar Melayu je kalau tak faham bahasa Inggeris. Tak perlu guna cakap bahasa Inggeris kalau tak faham konten, tak faham benda pun, tak perlu. Kalau awak lebih selesa guna bahasa Malaysia, Nur Yana. IR tu dekat mana? Dalam komponen mana satu? IR dalam komponen mana satu? IR tu dekat mana? Dalam komponen mana? Dalam CPU ke? Dekat mana? Dalam komponen mana satu? Ha? Dekat mana? Nur Iliana, IR dekat mana? Cemilan pun baru nak type. Kenapa baru nak type? Padahal bukan dari dalam. IR ada dalam control unit. Dalam dengan dari pun tak. Dari it is from. Dari Kuala Lumpur ke Tanjung Malim. Saya tanya IR dekat mana? IR dalam rumah. IR dalam control unit lah. Bila saya tanya awak dekat mana? Awak dekat college. Awak tak cakap pun awak dari college. Kalau saya tanya awak daripada mana? Awak cakap dari college. Perkataan pun kenalah exactly use the correct word. Dari, hantar, simpan. Awak kan orang Melayu, orang Malaysia, gunalah ayat dengan betul supaya saya senang faham. Primerlah cepat, baru nak type. Zain Kazing, what do you understand? Let me know. Allahu Akbar. 2 jam dekat sini je, bila nak habis ni? Ding Ali, what do you understand?
Hello, sir. Can you hear me?
Dengar.
Hello?
We can hear you. We can hear you. Come on. Hurry up.
Sorry, before my problem. My understand is we already get the address and from we already from the MAR and copy the contents from MDR to IR, and the IR.
Ding Ali, please repeat. Starting from, repeat, starting from register the address into MAR, and the address is, we get the address from the PC. So that's the starting point. Get the address from PC and register it into MAR. And what's next? You already have the address in MAR. So what we can do with the address? Tak faham lagi. Penatlah. Ding Ali, what we can do with the address? You already have the address.
Calculate the address.
Ya Allah, ya Tuhan. Wait, after we have the address, we find out the location.
We already get the address.
After we have the address, we find out the data using the address. Find out the data based on the address. In the memory, we use it. We use the address to find out the data. That's the purpose of the address. In the address, it has data. So after you find out the data, the data is already found. What's next?
MDR load data from memory to CPU.
After we find out the data in the memory, we register the data into MDR. There is no CPU at all. Your friend never say about CPU, you know. There's no CPU words. Are you listening to us or not? We never talk about CPU. We talk about MDR copying, IR, PC. No CPU at all. Where are you going, Ding Ali?
I guess I'm confused.
Apa you confused?
You see a half Malay or half English. I get some.
That's not the answer, Ding Ali. I don't want to listen that. You have notes.
Okay, wait a
Do
second.
not pointing your finger to me. Do not pointing your finger to me. I don't like that. It's your task to understand everything. Learn. You have notes. Read the notes. So repeat everything. Start from the beginning. Come on, cepat. Hurry up. Ding Ali, where are you? We are waiting for you. Do not wasting our time.
I'm still thinking for the answer.
Why you are so slow?
So I don't know I'm right or not, but I think MDR well we already get the address from MAR, and MDR will read address from MAR.
MDR will read the address from MAR. MDR will read the address from MAR. Do you know the purpose of MDR?
Yeah, MDR is read and write data.
Read and write data? Hello, MDR is the place to register the data, Ding Ali. The name is memory data register. Data register. So the register for data.
Yes, I mean
What is that? You told us that the MDR is used to register the MAR from the address from MAR. What do you mean?
I mean, MDR is the data read from the location by MAR.
Can you repeat everything from the beginning?
Beginning from the copy the contents of PC into the MAR and send the read signal to memory and copy contents of MDR into R, and the MDR read load data from the location by MAR.
MDR load data from location by MDR. I think you have a language problem now. This is not the language class. I don't know how to explain to you. It's so many times I've told you. You listen to my words, Ding Ali. You listen to my words. Jun Zuanli also. Listen to my word carefully. I repeat for so many times. Listen to this. Listen to this. Dengar ni. Yang lain pun sama juga. Dengar ni. Listen to this, Ding Ali and Jun Zuan Lee. Don't make me repeat so many times. The first step, copy the MAR, the address, copy the address into MAR. Where the address coming from? The address is coming from PC. So copy the content of PC into MAR. So what is the content of PC? The content of PC is the address itself. I repeat, copy the address into MAR. So where did we got the address? We got the address from the PC. Satu-satu nak kena ajar apa tu sangat ni. When we have the address MAR, when we have the address in the MAR, we find out the location based on that address. Find out the location based on that address. 10 kali ulang tak faham. Yang lokal pun sama tak faham. After we find the location based on the address in the MAR, we take out, we copy that the data in that location, we copy the data into MDR. And then copy the data in the MDR into IR. And then PC equal to PC plus 1. That's it. Apa masalahnya? What's the problem? Aduh. Sekarang ya Allah, kurang ni lah saja buat aku marah. Ding Ali, let me know. Tell me what's happening.
From beginning, I already understand.
Tell us what is happening.
Okay, and first, we copy the address from PC to MAR, and we send the read signal to memory.
No.
Oh, okay.
No, after we register the data the address in the MAR, what's next? Find out the
address.
Find out the
find out data and
find out the location.
Location.
Of the data. Yeah, I used this word just now. Yeah, find out the location of the data. Don't tell me that you do not understand because I'm using Malay language.
Yeah. Besides
English one. Hey, listen to me. Hey, listen to me. Find out the location based on the address. Use that sentence in your answer. Find out the location based on the address in the MAR. Why is so hard for you to use that sentence?
Yeah, find out the location from MAR, and we take out the address from
The
MAR.
data.
From data, copy the data to MDR, and
take out the data from where?
From MAR.
From the location, not the MAR.
Yeah,
MAR is for the address.
Yeah.
MAR is for the address, Ding Ali. MAR is not for the data.
Yeah,
MAR is for the address. So find out the location of the data based on the address. After you find out the location, then you can find the data because the data is in the location, not in the MAR. MAR is address. Can you understand me? We do not take the data from the MAR. We take the data from the location. Aduh. And we find out the location based on the address. Why is so hard for you to understand, huh? So what's next? After we found the location, after we found the data in the location, what's next?
We take out the location.
What?
We take out the data.
And
copy the data from MDR to IR. And
no. We take out the data from location and what we did to the data.
Read data.
What we did to the data that we just take it out from the location, Ding Ali.
We take out data from location to MDR.
Register, not.
Register data.
Oh my God. So what did you do to the data that we just take it out from the location?
Register data.
Register the data. Where? In the
MDR.
That's
register
the
data.
answer that I want. Okay, after you register the data in MDR, what next?
Copy the data from MDR to IR.
Yes, that's the things that happen. Copy the data in MDR into IR, and then next.
And next, PC plus one.
Why it's so hard for you to understand? Apa lagi belum? Jun Zanli, tell your friend what is happening from the beginning.
Yes. I tell my friend.
Go ahead. Don't wait. Don't make we wait for you.
Okay.
What is it?
Wait a minute, teacher.
Yeah.
Hello, doctor.
Hurry up. We are waiting for you 5 minutes already.
Because my night is unsuitable. Sorry, doctor.
Hurry up.
Yeah. Copy the address into MAR. Address got from PC and find out location based on address. Copy data of location into MDR.
Pardon, sorry. Pardon. We already registered the data into MAR, and what's next?
Next is is copy data MDR to IR.
Wait. We just registered the address into MAR, and what is the next step? After we register the address into MAR.
Next step, copy data.
No, we find out what?
Oh, find the location. Yeah.
Based on?
Location based.
Based on the?
Based on address.
Yeah. And then after we already found the location, what's next?
Find the location. Next is copy data of location into MDR.
Yes, and then?
Let me think. Next. Copy data MDR to IR.
Next.
Next, PC becomes PC L1.
PC at 1.
Yeah,
Correct.
PC L1.
Is it hard for you to tell
Yeah.
me about the process? Is it hard or easy?
Yeah, I think it's easy.
Primala, control register address, control unit register address into MAR by the control unit.
Yeah.
Then trace the data from address. Then trace the data from address in MAR. Data from memory will be registered. Copy content of apa ni? Okay, then trace data from address.
Doctor, my friend Junxian, he helped me about that. I thanked him. Yeah.
Yeah.
Yeah. Okay. Thank you, doctor.
Okay, welcome. Junzian. Oh, Junzian.
Yeah.
Come on.
Yes, teacher.
Tell
Yes,
your friend
teacher.
what is happening in the process.
What, teacher?
Tell your friend what is happening.
Yes, I tell my friend. This class teach us.
So after, okay, the first step is register the address into MAR, and what's next?
Wait. Address code for PC.
Then?
Then for find out algorithm based on addition.
Address in, okay, find out the location based on address in MAR. Okay, next.
Yeah. Yes. Next. Copy that for attention into MDR.
I'll take out the data from that location into MDR. Okay, next.
Fight go back.
Go back. You already got the data into in MDR. So what's next? Copy the data from MDR to
MDR.
Yes, copy the data. Okay, from MDR to
AR.
Okay, next.
Next PC because become PC plus one.
That's it. It's easy, Junjanli. It's not so hard. Okay, thank you.
Thank you, teacher.
谢谢。
谢谢老师，谢谢。
Control unit register address. Primala, control unit register address into MAR by the control unit. Then trace the data from address and data from memory will register to MDR. Copy. Okay. So that is the slide 13 all about. Is it the process how to fetch the instruction from memory. And next, decode the instruction. Decode the instruction. So to decode the instruction, the step is, the first one is first identify the opcode. And then depending on opcode, identify other operands from the remaining bits. So what does it mean? So now you open up your table, ISA table. Do you have the ISA table with you?
Yes, sir.
Yes, sir.
Open it up now. Junzian Lee, do you have ISA table with you?
Yes, I have. Yes, I have this.
Okay, good. Okay, now we look at the ISA table and we try to decode the instruction. This is the second phase, decode the instruction, the second phase. Okay, what is happening there? First, identify the opcode. So I already give you the example here, X3000E, 0010010000000011. We have 16 0 and 1. You can count. You can count it. 4, 8, 12, 16. So 16 bit. Do you see that, Junzan Lee?
Yeah. I can see.
Okay. So the first step is for the second phase, decode the instruction. So the first step is to identify the opcode. So what is the opcode for this instruction, Junzian Lee? What is the opcode for this instruction?
Wait me, teacher.
If you see the ISA table, the opcode is bit 15 to 12. Bit 15 to bit 12. So you
Yeah.
So what is the opcode for the instruction? For example, 0,
0 0 1
4 bit, 0 0 1
0 0 1 1 0
0 0 1 0, only 4 bit. 0 0 1 0, only 4 bit. You got that, Junzian Lee?
Yeah.
Okay. Okay, 0 0 1 0. Next, you check 0 0 1 0 using ISA table. So 0 0 1 0, what is 0 0 1 0 all about, Junzian Lee? 0 0 1 0.
0 0 0 1 0
Ada tak? 0 0 1 0 0 1 0.
It's LD.
Yes, LD, good. So this instruction is for LD. LD means load, 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 yeah? Okay. So now, this instruction is load. So what is next bit for? We have 3 bits. 3 bit is for DR. DR is the location. Location in CPU. You write something on your note, Junzian Lee, the IC table. So for LD, LDI, LDR, and LEA, all the DRs means destination. So the destinations means the location in CPU or temporary TEMP. Do you still remember that where is the TEMP located? Junzian Lee? TEMP. Do you still remember?
Yeah, I remember a little.
I remember a little. So TEMP, okay, I ask you, the TEMP located in memory, CPU or CU? Check the von Neumann model in chapter 4. Chapter 4.
Chapter 4.
Where is TEMP located? Is located?
Maybe CPU.
CPU. In CPU. So now DR's main location in CPU, which is temporary TMP. You got that?
Yes.
Okay. LD, LDI, LDR, LEA, DRs means temporary location in the CPU. So we need this location because of what? Because when we load, use this word, when we load the data from the memory, okay, we need to load the data to the temp. So from memory to the temp. So destination is in temporary. So DR means destination. Destinations means temporary. So PC offset 9 means the address. The address where we can find the data. So if you want to calculate the address, we need if you want to find the data, we need to calculate the address. After we find the address, we already calculate the address, we can take the data from that address, and of course we register it into MDR before we set it to temporary. So now how to decode or calculate or evaluate the address? Okay, first, now get back to our slide. We know that this 4-bit is the opcode, which for this example, this opcode is for load. So the process is load. And then where to load the data? So the answer is we can load the data into register 2 here. Why it is 2? Because it's 010. 010 means 2. Let's say if we want to load the data into register 3, so the bit will become 011. 011 means 3. Let's say if we want to load the data into register 7, so 010 will become 111. 111 means 7. If 000 means 0. So we have 8 register. We have 8 temporary storage, which is RO, R0, R1, R2, R3, R4, R5, R6, R7. So we have 8. 8 temporary register, which is R0, R1, R2, R3, R4, R5, R6, R7. Okay, do you got that? Do you understand that, Joseli?
I understand.
You understand. Okay, now our task is to evaluate the address. Okay, because we already know where is the opcode, what is the destination register, and what is the value of the PC offset 9. You can see here PC offset 9. We have 9 means 9 bit. We have 3, 6, 9. 9 bit here. So in decimal, what is this binary represent? 000000011. What is that?
3.
3. 3, in decimal it's 3. So now we know the offset is 3. And our next task is to evaluate the address. Okay, go to the next slide. Okay. Okay, I already copied the same instruction here. It's similar like before. So to calculate the address, we need to add PC. PC is the address, the current address here, 3000E. Okay, we add 3000E with 3 here. The 3 here, 3 here. Okay, 3000E plus 3. What will we get?
3011.
3011. How to calculate it? After 3, after E is? After 3000E, we
F.
got plus 1 is
3000 F.
F. And then plus 1?
3010.
3010. And then plus 1?
3011.
3011. Okay, so 3011. 3000E plus 3, we will got 3011. Okay, and then we need to add 1. 1 by default. By default, because we have PC offset 9. PC there means the word PC there means you need to add the address just now with 1. So 3011 plus 1 is 3011 plus 1.
3012. 3012.
Yes, 3012. So the data that we want to copy from the memory into temporary located in the 3012. The address is 3012. So we can find the data in 3012. So the data is kept there. The data is there. So that is how we evaluate the address. So now we already know the location of the data, which is the address of the data is 3012. Okay, so what's next? What's next? The next slide is what? After EA, OP. OP is fetch operand. Fetch operands mean after we know the location, we take out the data from that location. We take out the data from that location and we execute any operation that we can do. Okay, what is the difference between the example that I give to you just now? Okay, the example that I give you just now is about the instruction that represent the loading process, not the arithmetic operation like add and end. Okay, so this execute phase means you do add and end. So for the example that I give you just now, the execute operation is not being done unless you already have 2 operands here. So means that in this case, if you want to do additional operation, for example, so we need to do 2 times. I means fetch, decode, evaluate, and what is fetch operand just now? Okay, the first circle is to get the first operand. I mean, the instruction processing will begin with fetch operand, fetch instruction memory, and then decode instruction, and then evaluate address, and then OP is fetch operand. That is the first operand, and then it's repeated again for the second sources, fetch, decode, evaluate address, and fetch operand. Okay, twice. Okay, at this moment we already have 2 operands. Okay, after we have 2 operands, then we can do execute process, the fifth phase. Okay, so to do the execute any operation, we need to give another instruction lah. Either it is AND, add or not. And then after everything is done, the result or the information will be stored into memory. So how to store the result? The step is write address into MAR and then write data to MDR and then send write signal to memory. So that is the process of instruction processing. Is there any questions? Is there any questions?
No, sir.
Soalan-soalan kalau tak faham. Yang perempuan-perempuan ni awak tahu tak apa yang saya ceritakan?
Sir, boleh ulang tak, Sir?
Ulang? Awak nak saya ulang 3 jam punya konten?
Bukan, yang start dari apa tu? Yang lepas identify opcode tu.
Lepas identify opcode. Lepas identify opcode. Fasa mana tu? Fasa decode.
Yeah.
Maksudnya lepas fasa decode is evaluate address, right?
Yeah.
Mudah je mula-mula dapatkan arahan daripada memory, which is fetch instruction from the memory. And then after we get the instruction, what's next? We decode the instruction. So how to decode instruction? I've already told you how to decode. Based on IC table, we need to identify where is the opcode, where is the destination DR, where is the source, what is the PC plus offset 9 value. You calculate everything. I already show you how to calculate the PC offset 9, where I add 3000E with 3 and then add 1. So that is one of the example how to calculate the address. There's so many ways to calculate the address. There are 3 or LD, LDI, LDR, LEA is the technique to calculate the address. There are 4 techniques to calculate the address. LD, LDI, LEA, LDR. So for the example just now, I show you how to calculate the address based on LD technique, which is add the address with the offset 9 and then plus 1. So for the example just now, we already add 3000E plus 3, we got 11, and then plus 1, we got 12. So the address of the data, the location of the data is 3012. 3012. Yang tu faham tak?
Faham.
And then after we already calculate the address, 3012, we take out the data from that location. Okay, that process is OP. We already go to OP. EA, we just evaluate the address just now. The technique that I show you is this phase, evaluate address. And then after we find we already got the address, we take out or we take out the operand or the data from that location, and then send it to send it to temporary. That is for the first operand, baru ada satu. To do add operation, additional operation or AND operation, at least we need 2 operands. Is it correct or wrong? Can you do or execute additional only using 1 number?
No.
Logically, can you do additional or subtraction only using 1 number? Can you did that?
No.
Yang perempuan tak jawab ke? Boleh ke tak boleh buat operasi tambah guna 1 nombor?
Tak boleh.
Yang lain tak nak jawab ke? Diam je. Siapa tadi? Seorang lagi diam ni. Nak sebut nama dia. Siapa nama yang M tadi? Bukan Mu. Siapa M tadi? Dah hilang. Dia dah hilang ke? Dia dah hilang. Sekali dia lah. Boleh ke kita guna 1 nombor untuk can we use only 1 number, single number to do additional process?
No.
Cannot. So that is why we need to do two times. I mean, fetch instruction from memory, decode instruction, evaluate address, fetch operand. That is for the first number. For the second number, we do again fetch operand, fetch instruction from memory, decode instruction, evaluate address, fetch operands. Two times. Means we take the two data from the memory. Okay, until this phase, do you understand what I'm trying to tell you?
Understand,
Yes.
sir.
So even though the instruction processing, this instruction processing only show us one cycle, actually this is the basic of the process. The basic, only the basic one. This is how we draw the circle, the cycle. But if you want to use this cycle, it depends on the instruction. For example, just now I already told you, if you want to do additional process, we need to do twice. Two times. Fetch, decode, evaluate, fetch operand. Two times. After we already have two numbers, and then we go to the EX, execute operation. This execute operation in ISA table, we only have three. Add, and not. You can see in ISA table, we only have add, we only have and we only have not. Only three. Okay, so after we execute the operation, these three operation, and then the last phase is store the result into the memory. So how to store the result into the memory? You can read from the slide. Right, okay, the step is, okay, for store instruction, data is stored to memory. Write address to MAR. Register the address first. And then register the result in the MDR. And then send write signal to memory. Finish. The result is already stored in the memory. Settle. Done. That is what we call instruction processing. Faham tak siapa yang minta saya ulang tadi? Saya tak nampak nama. Boleh dapat tak?
Boleh.
Boleh betul-betul ke boleh sebab takut? Do you really understand what I'm trying to tell you, or just because of you get scared of me? Dah tak jawab. Saya tanya awak ni. Who's that girl? Dia suruh saya ulang, lepas tu dia diam.
Saya, sir. Boleh. Saya tak faham pasal yang twice tadi tu, yang apa?
Dua kali data tadi, dua kali pusing. So sekarang faham?
Dah faham.
So the two times the two time process is depends on the instruction. So even though the cycle here only show us only one cycle from fetch to store, but it still depends on how we use the instruction. If we want to do additional or and or not process, we are not okay. For and add, we need to have two numbers. But for not, only one number is okay. So for not, it doesn't matter if you want to use it. Okay, if you want to do just one cycle. But for add and end, at least you need to do two cycle to get two numbers. Okay, fetch, decode, evaluate, fetch operand. Two times. And then after we have two numbers, then we go to the next phase, which is execute operation, EX. Okay, after we do the operation, then we store the result. Okay, any questions? After we understand this, okay, I give you, we break for 5 or 10 minutes, 10 until 4:30, and then we will get to the next slide, which is chapter 5. Chapter 5, Okay, lepas ni siapa, who have class after this? Ada yang ada, siapa ada kelas lepas ni? Okey, kalau tak ada, boleh tak kita sambung dengan kelas sebab kita dah 2 minggu tak ada kelas?
Boleh, sir.
Primella, can we proceed with our class after 5 o'clock? Can. Zhang Kaizing, Ding Ali and Dun Zanli, can we proceed? Tengok saya kena tanya seorang-seorang Pelik kan kelas ni. Ding Ali, Kan Zaizing, Zhang Kaizing and Dun Zanli, can we proceed with the class after 5 o'clock?
Yes, sir. Can.
Yes, sir, teacher.
Because we already missed 2 weeks the class missed the class for 2 weeks, so we already we only have how many weeks? This week is week what week Minggu apa? Minggu 12 ke minggu 13? Nobody knows. 11.
Yeah, 11.
11, 12, 13, 14. We only have 3 weeks. And we are not doing the assignment yet, the individual assignment and the group assignment, Are you? So we need to, I'm trying to finish up the syllabus as soon as possible so I can give you times to do the assignment. So we take 5 minutes break. 10 minutes break, and then we continue with our class. Okay. Remain in this class. Sometimes, like just now, we have 12 and 11, but now we have 8. 9, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So how many of us actually discuss? Because if the attendance is not is not good, I will block, or I will I will bar the student from the exam, so the student can sit for the exam. So as for today, I will take the name. I will take your name, and then to those who are not coming for at least 2 weeks, I will bar them from the exam. Wait. So now we have Anis. Anis, are you there?
Yes, sir.
Anis. And then we have Ding Ali. Are you there?
Yes, sir.
Okay. And then we have
Yes, sir.
Okay. And then we have Denzenli.
Yes, teacher.
Okay. And then we have Nor Eliza.
Yes, sir.
And then we have Nur Ilyana. And then the last one we have Primila. Oh, Zan Kaizing, Primila. Pascal, and we have 8. The 8th student is Zhang Kaizing. So please remind your friend if they're not coming at least for 2 times.
Hello, doctor. I'm Zhang Kaixing.
Zhang Kaizing, yeah.
Yeah.
Okay. So please let your friend know if they are not coming for 2 times, I will bar them from the examination. And for today, as in my record, I only have 8 students starting from Anis until Zhang Kaizing. So for those who are not who are not record their attendance for this evening, I just apa nama? Wait. I treat them like they are not coming to the class. Tadi saya ada perasan Nur the girl with the name is starting from M. I'm not sure who is she. Maizatul, dia tu ada ke tak ada sebenarnya? Dia dekat mana? Dekat OC ke dekat rumah? Boleh tak suruh dia datang kampus? Kalau datang kampus, boleh saya buat kelas online di depan dia. Maksudnya, kan, you all online, dia face to face dengan saya. Buat dekat bilik, dekat office saya pun boleh. Cuba tanya dia, boleh tak dia balik kampus? Saya rasa dia tidak sihat. Kalau tak sihat, kenapa tak beritahu ada MC bagai kan? She need to let us know lah if she's not well. Okay, lagi siapa? Maizatul, lagi siapa yang nama-nama kawan-kawan you sepatutnya ada ni? Ada perasan seorang Indian guy, rasanya Nicky ke nama dia? Ada tak siapa kenal? Nama dia tak sure lah. Nobody recognize him?
No, sir.
Nobody. Tak apa, it's okay. So we just, okay, so at least now I have a list of students, 9 of you, including Maizatul. And please, if you have any information about your friends, just let me know, because as for this week, the attendance that I list down is only contents of these 9 students lah. So for next week, if the same person are not coming, so I just I just release the bar exam the block from the examination. The letter, I will release the letter lah if they are not coming for next week. So for those who are coming, we just proceed to the chapter 5. Okay. Cool. So chapter 5 is the is continued from the chapter 4, and if you understand chapter 4, chapter 5 is easier for you to understand lah. So basically, if you the slide that I skip, you just skip the slide. Any slide that I skip, you skip the slide as well. Don't read it. So for this one, I skip. Okay. Okay, this one. This is just the theory. Okay, we can skip this slide too. Okay, addressing mode. Okay, this slide, slide 4, it tells you that we have 3 types of instruction. If you see the ISA table, okay, in ISA table, we have so many instruction. Okay, starting from starting from add until reserve. And some of the instruction I already told you to take it out from the list, right?
Yes, sir.
Okay. So we just focus on the instruction that in the list, yang mana the instruction that I already list it out of the list, you just ignore it. Yang perempuan ada tak saya dah beritahu kan yang mana masuk, yang mana tak masuk kan?
Dah.
Okay, good. So now, okay, from the remaining instruction that we need to focus, okay, we can break down the instruction into 3 types. Okay, the first type is operate instruction. In the ISA table, we only have 3 operate instruction, which is add, and not. Add and not. We have 2 add, 2 type of add, 2 type of and 1 not. Is it correct?
Yes, sir.
Okay. Yes, sir. Okay, good. Refer to your ISA table, ya. Jun Zianli, refer to your ISA table, ya.
Yes, teacher.
Okay. So for this operate instruction, the component in the von Neumann model that involve for this instruction only CPU. I repeat, the component that involved in this operate instruction is only CPU. So it does not involve memory. It does not involve any component except CPU. Because in CPU, we have temporary, we have register, and we also have ALU, arithmetic and logic unit. Okay, so the arithmetic and logic unit will execute the operation, the add and 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 NOT, while the temporary, I mean the register, the temporary will keep the data and the information. Okay, please remember data is something that not has been processed yet, while information is referred to data that has been processed. I repeat twice. Okay, the temporary or the register will keep the data and the information. The data is refers to something that have not been processed yet, while the information is refers to something that or data that have been processed by the ALU. Okay, guys, you got that?
Yes, sir.
Okay. Now, we also have the instruction, the data movement instruction type, which is it refers to LD, LDI, LDR, LEA, ST, STR, STI. Okay, LD, the part all words that start with L is refers to the technique of LD, LDI, LDR, LEA is a technique of calculating the address when we want to load the data from memory to CPU. Okay, while ST, STR, and STI is a technique of storing the result or the information from CPU to the memory. So that is why the components that involve in the data movement instructions are memory and CPU. And the last type of instruction is control. So in our class, we only use BR and trap. BR stands for branch. Okay, trap is refers to the, I will let you know later because it's quite technical. So basically, we have three type of instruction in ISA table. You can classify, you can divide or classify or categorize the instruction in ISA table to these three type of instruction. Okay, so do it now. So at least you are not confusing what type of the instruction. Yeah, so you can do it now. Write some note over there. You classify or you categorize or you group the instruction based on its types. Either it is operate or data movement or control. That's it. And then okay, the data type is 16-bit. So we have 16-bit of 010101. And then addressing mode, okay, it's nothing important about these modes because we will do it practically. So okay, operate instruction, we have add and not. So this instruction do not reference memory, of course, because it only involves CPU. And there are two type of add and two type of AND. Okay, two type of add and two type of AND. And we can show the process by using the data flow diagram. So we can draw the process, we can express the process, or we can show the process using a diagram, where the diagram is known as data flow diagram. So we'll look at the data flow diagram after this one by one. It's easy, it's very easy. Okay, for example, okay, the first one is not. The operate instruction named not. So for not instruction, the opcode is 1001. You can refer this in ISA table. And then after this opcode, we have destination register, which is referred to the temporary storage in the CPU. And we have source. Source also refer to the temporary storage in the CPU. And then we have 111111. This one is permanent. We cannot change it. 1111. 6 times of 1. So the data flow diagrams, we can express this flow using the data flow diagram. You can see up here we have register file, which is temp lah, temp. Temp. We have 8 register files starting from R0 until R7. And then the operand or the source, after we move the data from memory to CPU, okay, so the data is already in the temp. Temp is in CPU lah, I mean. So to do the NOT process, what is the step? The first step is to send the operand from source register, SRC or SR, to the ALU. This one is happening in the CPU itself. There is no involvement of memory, only in CPU. So the operand will be sent to the ALU, and then ALU will do the arithmetic or logic process, and then the result or the information will be sent back to the temporary storage in CPU. So here in this diagram, you can see we are using 2 registers, which is the blue one and the green one. So 2 registers. But here we have there is a note at the bottom here. Source and destination register could be the same register. So it is correct if, let's say, the first step, the operand is sent from source, the blue one, to the ALU, and then the result will be sent back to source. I mean the blue one. It's possible. It can. It's possible. So the only thing that you need to change is the label lah. The labels mean during the first round, the blue one is act like a source register, and then for the second round, the blue one is also act like a destination register. So you just change the label SRC/DST. SRC/DST means that in the first round, the blue register is used as a source register, while the second round, the blue register is used as the second register. So you need to change the label source/DST. You need to do that if the source and destination is the same register. If not, you can just use 2 register and you can show the data flow for the data flow diagram similar like in this slide. Okay, faham? Understand?
Yes, sir.
Junzian Lee,
Yes, teacher.
really? You understand what I'm trying to tell you?
Yes. That's ALU first SRC to ALU.
Sorry, pardon? Sorry, again.
SRC SRC to first SRC give ALU. So ALU give DST.
ALU will do the NOT process, the NOT operation. And then the result will be sent back to DST.
Yeah.
So DST and the SRC and DST are located in the TEMP. If you refer to von Neumann model, this register file is a temporary register itself, TEMP, in the CPU. If you refer to the
Okay.
Depan kat tangan tadi ada orang kat tangan ni. Anybody raise up their hand just now? Can seriously tak sihat? Tak ada Anis?
No,
Jawablah
sir.
no. Nur
No
Eliza?
question, sir.
Jawablah no juga. Jangan biasa tanya tak berjawab. Nur Iliana? Nur Iliana? Primela? Primela? Lain kali kalau saya tanya tolong jawab ya. Boleh?
Okay.
Okay, sir.
Tak ada masalah. Memang rajin jawab yang lain-lain ni. Tolong jawab ya. Boleh ke tidak?
Boleh, sir.
Boleh, sir.
So for the next slide, end and add register. You can see how does it look. The flow, the data flow is starting from both source is from temporary, and then it will send to the LU in the same time, synchronous. That's why the first and the second arrow, the number is similar. Means that it will be sent concurrently, synchronous to the ALU, and then the ALU will do the add and end process, and the result is sent back to the temporary storage or TEMP. So okay, the difference between the end and add register and add and end immediate is the fifth bit, where for the register mode the fifth bit is 0, while for the immediate mode the register is the fifth bit is 5. So in the command, the different to do a command, the difference between the register add and end and the immediate and add is like this. For example, okay, this is for the first add and end, where the content of the first register will be add to the second register and then will be kept in the destination register. Okay, this is for the first add and end, where it is refers as it is known as register. While the immediate add and end, the comment is like this. So the content of R7 will be add to 6 for example 6, and then to be kept in R5. So means the content of the register we add it with the real value of the immediate 5. So that is the difference between the first add and end and with the second add and end. Any questions? The content of register add with the content of the register, while the other one, the content of the register add with the real value in the instruction. Okay, any questions?
No question, sir.
Seriously, no question? Okay, like this one, both operand is coming from the temporary, while the immediate mode, the first operand is from the temp, the source one, while the other operand is coming from instruction register, bit 0 until bit 4. Okay, so one from temporary, one from control unit. This one is for the immediate mode, and the sun extension here means if the in instruction register, the 4 bit here, bit 0 until bit 4, if it is start with 1, if the number or if the bit start with 1, you need to do the the flip and plus 1. I mean the number is negative. So if you want to know the real value, you need to flip the number and add it with 1. Okay, this is only if the first bit is 1, which is negative number lah. But if the negative is the IR is positive, you just add it like usual. No need to do flip plus 1. Setakat difaham ataupun ada apa-apa nak tanya berkenaan dengan apa-apa saja?
Understand, sir.
Yang lain tu ada mulut tak?
Faham, sir.
Anis faham tak? Korang ni kalau korang malas nak jawab, saya malas nak mengajar lah.
Sekejap sir.
Primela faham tak? Korang tak respon lah. Penat tau kalau mengajar tak ada respon ni. Nanti korang jadi cikgu, student tak jawab, korang tahulah sakit hati macam mana tau. Dah lah nak mengajar satu hal, bercakap satu hal, membebel satu hal, nak bagi faham satu hal, tak faham-faham satu hal, ulang 10 kali 10 satu hal. Bila tanya pun tak jawab. Awak ingat saya tak panas. Kalau awak kat tempat saya, awak pun panas tau dengan student yang macam ni. So kalau nak give and take, kalau nak maintain the mood, tolong respon kalau nak maintain the mood, tolong respon. Korang ni nak ilmu daripada saya tau. Saya nak mengajar elok-elok. Saya boleh je buat tak tahu. Pandai-pandai korang lah, boleh je. Boleh je saya buat macam tu. I don't care about my penilaian. I don't care about that. Saya dah 20 tahun mengajar. I am in the UPSI since 2003. You all pun kat sekolah lagi. Saya dah mengajar di UPSI. I've been teaching in UPSI since 2003. Just after my graduation day. So saya dah tahu sangat dah apa masalah student yang mana jenis tak jawab ni, memang saya tak akan ajar. Pandai-pandai korang lah. So kalau nak maintain the mood, if you want to maintain the vibes of the class, please respond. Boleh ke tidak?
Boleh sir.
Boleh sir.
Boleh sir.
Kalau korang malas, saya pun malas So we already done with the operate instruction. So now we go to the data movement instruction. So as I said, as I told you, LDR and LDI is technique to load the data from memory to CPU, while the ST, STR and STI is the technique of storing the information from the CPU to memory. So the data flow diagram is look like this. So for load, the first step is to calculate the address. So how to calculate the address of the data, the location of the data. So we need to add the value of PC and with something from instruction register. Like we did just now, we add 3000E plus 3. Ingat lagi tak?
Ingat.
Ingat sir.
Yang buat tadi tu. Buat 3000E plus 3, so that and plus 1, so that is how we calculate the address, PC plus something from IR. So both is happening synchronously. That is why the number is 1 and 1 in the circle, and then the PC and IR we will send to ALU. ALU will calculate the address automatically, but for if the question asks you to do it manually, so the way how to calculate the address is similar like what I show you just now, the 3000E plus 3. Okay, so after that, the address will be registered in MAR, the second step, and then the address will be used to find out the location in the memory. While once the location is found, the data from the location will be taken out and will be registered to MDR. And then after the data is already registered into MDR, the data will be sent to the register file. And again, where is the location of register file? It is in the memory. CPU. Siapa yang jawab tadi tu? Saya tak nampak nama.
Eliza.
Bagus. So dalam CPU, so you can see how the data is taken out from memory to CPU. Nampak tak?
Nampak.
After the data is taken out from memory to CPU, okay, this process can be continued with NOT, AND, or ADD process. So this picture or this data flow diagram can be combined with operate instruction. Let's say in the same diagram, you need to show the load, the operate instruction, one of the operate instruction, either it is AND, add or not, and the store process. So using the same diagram, you just draw the line and then put the number on it. So please differentiate the line using color and numbers. Let's say load, you use red color for the arrow and the numbers. And then the operate instruction, maybe you can use green for the arrow and the numbers. And for the store, you can use another color, maybe blue, to represent the arrows and the numbers in the circle. So use the same diagram if you want to show the whole process of the loading, the operate instruction, and the store process. So from here, you can combine, let's say loading, we already load the data from memory to CPU, and then continue with not. Let's say continue with not. So you just continue with not. Okay, from source, send to ALU, send back to destination. So using the similar diagram, like this, okay. Let's say during the first round, the blue one is the destination, right? Because we want to take the data from memory to the temp. So of course, the blue one in the test register file will be labeled as destination. But if you want to combine this with the operate instruction, of course the destination will be source of the operation. So you label the blue one with source, destination/source. It means, okay, for the first round, the loading process, the blue one is destination. But when the operate instruction is executed, the blue register will be the source. Okay, so give two names to this register. First round is destination. Second round is the source, because the first one is for loading and the second one is for operate instruction. So that is how you combine the diagram of the load, store, and the operate instruction. So this is for how we take out the data from memory to CPU. And to store the data from CPU to memory, as I told you, LD, the partner of LD is store, ST. So again, we calculate the address by adding PC and something from instruction register. Okay, ALU will did this. Okay, ALU will process or calculate the address. And then in the same time, the result, the product of the operation will be sent from register file to MDR. Will be registered from temp to MDR. And then for the second step, the address that have been calculated by the ALU will be registered into MAR. And the last step, the address that have been calculated and registered in the MAR will be used to find out the location in the memory. Once the location has been found, the result or the information that have been registered in the MDR will be sent to that location in the memory. Is that clear?
Yes.
So can you repeat for the last step?
Repeat
step
for
number
the
three?
last step number 3. Okay,
Yes.
step number 3. Okay, you need to make sure. Okay, first of all, there is a data registered in the MDR. That one is step 1, together with calculating the address lah. Okay, so the process execute synchronously. Okay, then the second step, the address that have been calculated by ALU will be registered to MAR. At this moment, we already have the data in the information, the result in the MDR. We only wait for the address. Once the address has been calculated, and then the address will be used to find out the location in the memory anywhere regarding to the address lah. And then after the location has been found, the data that have been registered in the MDR will be kept into the memory. Okay, so how to calculate the address? Again, address, the current address plus offset 9 and plus 1 because we have PC here. So that is how we calculate the address. PC offset 9 means 9 bit, 9 bit. So we need to calculate the 9 bits. What is the value, the decimal value, and then we just add it to the address like we did just now, and then we plus 1. So any questions according to this store technique?
No, sir.
No question, sir.
Okay, boleh faham ke Juzali? Shun Li, are you there?
Yes, I'm here. I'm here.
Clear, okay. Ding Ali?
Yes, clear.
Okay, good. So this is the technique how to load and store the data. And then, okay, next we have LDI and STI. I means indirect. You will see the difference between LD and LDI as well as ST and STI. So look at LDI. Okay, what is happening while if we are using LDI to load the data? Okay, first of all, we calculate the address. It's similar like load LD just now. So how to calculate the address? The value from PC will be add with the value from IR. Both of this value will be sent to ALU. ALU will do the calculation lah. So after we get the address will be registered into MAR. And then the address that has been calculated and registered into MDR will be used to find out the location in the memory. Okay, once the location has been found, the data from the location will be taken out and registered into MDR. Okay, here is the point, the difference between the LD and LDI, where okay, if we use LDI, the data has been registered, will be registered again as an address. So the data will be registered again, but the data will become a new address. And then that new address will be used to find out the location. Okay, after the new location has been found, the data will be taken out and registered into MDR, and that data will be sent to CPU, which is temporary register. So if you see the difference here, okay, there are two the address that have been registered in two ways. The first one is the address that calculated by ALU, and the second one the address that taken out from the memory, the second address. So that is the difference between LD and LDI. So it's similar like STI. The first time, the first step, the address is calculated by the ALU. Okay, ALU, the value from PC will be added with the value from IR, and then the address will be registered into MAR. It's similar like LDI just now. And then the address will be used to find out the location from the memory. The location in the memory. And then after the location is found, the data will be taken out and registered into MDR. Okay. And then the data in the MDR will be registered again into MAR. So the data will be the second address of this process. Okay. Okay. Now we have the new address, and the next type is number 5. Okay. The information or the result will be registered into MDR. So now we already have the new address in MAR. At the same time, we already have the data in MDR. So the last step is the new address will be used to find out the location in the memory. Okay, while after the location has been found, the data in the MDR will be sent or stored into the memory. So basically, you just look at the number. It's already have the number, and you can understand the flow of the data, how they keep the data or store the data into memory. Okay, it's quite, actually it's easy if you reach or if you read this slide at least for 2 times or 3 times, you will get the clear picture how it works. The point is you need to calculate the address twice. The first calculated by the ALU, the second one is just taking the address is just we just take the address from the memory. It differ from the load just now, load LD and ST. We need to calculate address only once, only one time. So that is why the second technique names indirect. Indirects mean the address need to be calculated twice, not only once. Okay, is that clear for LDI and STI?
Sir, I have a question. For LDI, the fifth arrow after the new location after new address is used to find out new location in memory, then the new location will be used to find new data and stored in memory. Is that correct?
Yes. The fifth arrow is to find out the location. It means the number is similar because it happens synchronized. You can imagine the arrow is moving synchronized. So once the location the searching process, once the searching process is executed, at the same time the data will be taken out once the location has been found. I mean the similar number means the process is synchronized. It's hard to imagine, but you just need to know that it is synchronized. That's why we put the similar number 5 and 5. Is that answering your question?
Yes, sir. But what about the sixth arrow?
The sixth arrow, the last one, means that after we got the data, the real data from the memory, and then we send it to the CPU lah. This one, 6. Because our aim is to load the data from memory to the CPU.
Okay, sir, understand.
Are you sure? Am I answering your question or maybe it's not clear or what?
Yes, it's clear.
Okay, any other questions from the girls?
Sir, I have to left, sir.
Kenapa? Kenapa?
Ada hal sikit.
Hal apa tu?
Actually, sekarang saya dekat tempat awam cari line and then tempat tu nak tutup, so I have to left first.
Kesiannya. Macam mana? Saya kesian tau dengan student yang macam ni. So macam mana Anis? Awak ada apa-apa? Sebab saya terpaksa habiskan kelas ni juga, banyak juga ni sebab dah tak ada kelas 2 minggu kan?
Boleh tak someone tolong sambung record sebab saya tadi ada record kelas.
Can someone help Anis to record the class? Kita tengok siapa yang baik dalam kelas ni. Saya dah penat mengajar ni.
I will try to record, sir.
Okay, thank you,
Okay, thank you,
One thing that I hold until now is if we help other people, God will help us back. Itu prinsip yang saya pegang. One prinsip that I hold until now. Okay, never mind. So any question from about the LDI and STI technique?
Sir, thank you sir. Saya left dulu ya.
Okay. Saya buat kelas ni untuk you all tau. This class is for you, not for me, because you will sit for the exam. So if you have question, let me know. If you are not interested, we can end up the class, and then you just go ahead with your own way or style of study.
So I have a question.
Ah.
For the 3 arrow, yeah, this where beside the address find the location and we take out the data to MDR.
Wait. Ding Ali, which one? LDI, STI, LD, or LD?
LDI.
LDI, huh?
Yeah, for the 3 arrow.
3 arrow.
Yeah,
okay.
we beside address find the location and we take out the data to MDR. And
Yes.
This MDR is not real it's not real data. So
yeah.
we need to do again.
Yes.
For this data.
Yes.
Okay.
It's not the real data, it's the address actually.
Address. Okay.
So number 3 is belong to the line from MAR to the red area in memory, and for the line from the red area to the MDR also 3, number 3.
Understand.
Okay. Nuriliana? Guys, I'm concerned. Saya bukanlah seorang yang tak concern. So, cuma bila tak respond tu, if you're not responding to my question, I feel like, I don't know whether you understand or not about my class. So that is why I make a decision to just wrap up the class and end up the class if there is no question or no response, because I don't know what is your progress in the class. So if you respond, if you ask me question, so I know your progress and I can do something. That's why I force you to ask me. So if you just keep quiet, so it's better for me to wrap up the class, because to me you understand all everything. Kan? But that thing is impossible because we cannot understand everything in a single time, in a single day, and it's impossible. So I really hope that you can ask me questions. But I just want to tell you this TOEFL diagram is important. It's important. It's important. So just mark that. My word. So this is for LDI and STI. And then the last one is for LDR and STR technique. Okay, so for the LDR technique, so to calculate the address, we need to add the something from IR and something from base register. So there is no PC value. There's no PC. So the address will be calculated by the ALU, and then the address will be registered into MER before it will be used to find out the location. Once the location is found, the data will be taken out and registered to MDR, and the last one, the data will be sent to CPU. Okay, settle. And then same goes to STR. Calculate the address first by using the value from IR and base. It's similar like LDR, there is no PC at all. No value from PC to calculate the address. Okay. And then once the address is calculated by the ALU, the third step is the result of the process of the add, and or not will be registered into MDR. And the last one, the address will be used to find out the location. And while the location is found, the result of the process will be stored into the memory. So settle. So for the LEA, I think LEA is a process to calculate the address and just keep the address into CPU. It doesn't involve memory. So this one is quite tricky, but it is rarely used in the exam. It's rarely used in the exam. Rarely used, jarang sangat. But to just let you know, the LEA is the technique of calculating the address and keep the address into the CPU. So how to calculate address? Again, the value from PC will be added with the value from IR, and then the result or the address will be kept into CPU. So this one is quite tricky because the address, as I said just now, the address will be not used to find out the location. Okay, but it will be kept into CPU. Okay, so settle. That is the technique of loading, storing, and add, not, and end as well. So that's it. So basically, what we have learned through the data flow diagram emphasize or it explain the process that happens in chapter 4. That is why I told you, if you understand chapter 4, you will understand this easily. So that is why just now I force you to understand chapter 4. Once you understand chapter 4, you know how to use the load word, the store word, the register word, and then if you know everything about that words, then it's easier for you to understand chapter 5. So any question until now?
No, sir.
No question. If there's no question, we will do exercise to enhance your understanding about the process. So normally in the exam, the address here, and the instruction here will be given to you. I repeat, normally in the exam, the address here, the address and the instruction will be given to you. Your task is to explain the process using commands. This is your task. So here we have 7 lines of instruction. So we will do this. Actually, it's easy. So we will do this as fast as we could. We just focus. Please give me your attention. Okay. So we start with 3050 FT6. 3000 and FT6. So that is the first address of the instruction. Okay, now look at the first opcode. So the first instruction is for what? What is the opcode for the first instruction? What is the first opcode? What is the opcode of the first instruction in binary?
LEA.
LEA. So remember, LEA is used to calculate the address and keep the address into CPU, right?
Yes.
So how to calculate address? So to calculate the address using LEA, we need to add something from PC and then we add it with something from IR. How many bit? 9 bit, offset 9. You see here, PC offset 9 to form an address. So now we look at the instruction. So what is the value of PC? PC is
3000 F6.
3000 and FT6. And now we need to add it with something from the IR 9-bit PC offset 9. So I think the last 9-bit, right? This one, right? 9-bit, you need to calculate 1, 2, 3, 4, 5, 6, 7, 8, 9. Is it correct?
Yes, sir.
Yes.
Okay. Now you see the first bit is 1, right? So 1 means what? What does it mean if the first digit is 1?
It's negative.
It's negative. If negative, what we need to do to find out the real value? We need to flip and then?
+1.
+1. Okay, just flip the number 0, 0, 0, 0, 0, 0, 0, 1, 0. 1, 0, and then +1. So what will we get?
3.
3. Yes, good. It's easy. So just ignore the first one here because all 1 will be 0. We just take the remaining bit here. So 1, 0, 1, 0 plus 1 is 1, 1. 1, 1 is 3. So 3 OF6 plus 3. What will we get? 305, 30F.
4.
4.
4.
3.
Don't look at the comment, yeah. Don't look at the comment. We
3.
do it one by one. 30F6 plus 3.
30F9.
30F9. Okay. 30F9. Sorry, it's negative 3. Negative 3. 30F6 plus negative 3. So what will we get?
30F4.
3, 6 tolak 3. 6 minus 3.
Oh, sorry.
30.
F3, then plus.
30F3. So we got 30F3, and don't forget to plus 1 because it is PC plus offset 9. You look at the ISA table. Look at the ISA table. Here, the label is PC offset 9. So we need to add with 1 because it has PC here. So 3000F. 30F.
4. 30F4.
30F4. So, and then the address is 30F4, and then we keep the address, this address into CPU. So which register that we will use? Look at the destination, the DR. The DR is from 11 to 9. So 11 to 9 is which one? What is the bit of how about others?